Screen. No one zoomed in. Just wait a minute. There's someone. Two. Wait another minute or two here. All right. Explode. All right, class. I'll take a look and see what polynomials, and then factoring. We get 1 day to do polynomials, factoring, GCF, differences, squares. Okay, we got 1 day. Okay. I don't know if I could. I'm going to take 2 days. I don't care. This is important stuff. And then this. Okay. Let me go this week. Y'all done factoring before, right? Not easy, is it, right? Yeah. Because it gets you the right answer and the teacher could be like, they've learned it. But all they've really done is crippled you. I mean, it works. Like if it's 2 things times 2 things, it works for that every time. And typically that's what you do in your head. You do the first, outer, inner, last, that's what goes on in your head. But if you've memorized that and you do that just to get that one type, then you can't do it if there's 3 or 4 things. Yeah, and you're like, I have no idea because I learned FOIL, right? The purpose of FOIL is so that you could do those easily, but it's not meant to prevent you from being able to do any other math problem, right? If you know the distributive property, FOIL comes from it. This is how it works. Once you've done enough problems, you recognize that, oh, it's always that, but it doesn't have to be FOIL. You can do them in any order. You see what I mean? Yeah. So we really want to be able to factor. So we want to be able to factor stuff that has a whole bunch of terms in it, because there's lots of different tricks. And it will show up again and again and it never goes away. I mean, these are your basics. Some of it you might not see for a while, like certain types of factors you might not see for a while, but you do need to know it. It'll pop up randomly in calculus because you'll need to be able to simplify stuff to do the calculus to it. And it's all algebra, and you need to be able to do it like it's nothing. see. We'll do a little more multiplying and then we're gonna skip to the next one. 8-3, start factoring. It's 4:06. We'll wait for them to come back. We'll wait another couple of minutes here. Bought round trip tickets to the Philippines in May. It's there. Like 40-hour flight one way. Yeah. I haven't flown anywhere in 20 years. Yeah. Philippines. Probably end up getting married. The girl I met on OkCupid, yeah. Danny, Danielica, Angelica. Let's see how it goes. Been talking to her for like 2 years. Originally met a girl from Thailand. She turned out to be nuts. Figured that out real quick. Yeah. I'm pretty patient. Pretty patient dude, but I do have my limits. Some things I know I just won't put up with. No, I never have. I flew to Panama once when I met my first wife's in-laws. Yeah. Yeah, I could handle it. Well, no, I flew to California. It seems like a long time ago. You know, like a 2-hour flight or whatever. That can't. But this is like flying to LA and then flying to Taiwan, and then I'll be in the Taiwanese airport for like 16 hours, and then I'll go to the States. And right now, like China's are randomly bombing Taiwan. Yeah, they do. The big ones have like sleeping pods for people. Yeah, it could be like 40 hours, something like that. 13 days from when I leave and from when I return, but like 4 of those are going to be around the airport. Oh, wow. Oh, wow. Well, that's cool. You'll be weird with all the time zone changes. They're like 10 hours off. It's gonna be a journey. The time thing's gonna mess me up. I'm leaving like the day after grades are due, and then I'm getting back like the day before summer semester starts. I don't have much transition time. All right, let's get started. We're still missing somebody, but too bad. So, like, if you're gonna multiply these, I already wrote this out. Oh, did I? Click recording? Yeah. You have this times that minus this times that. So that's what I've written right here. So now if we distribute those, we got a, we got a 4u times a 2u. And then we have a 4u times the v. And then we got the minus 3v times the 2u. And then we have the minus 3v times the v. So if you look at this is why they tell you FOIL. Again, it only works for two things, right? Right, you have the first two terms, the last two terms, and then OI, right? Inner, wait, F, which ones are these? The first two, yeah, those are the first two. Those are the last two. These are the inner ones. Inner, so these must be the outer, all right? But you don't need to memorize FOIL. You just know you're going to get this times this. You're going to get that times that. You're going to get those times those and those times those. You get all the combinations, right? So when you see something like that, you should be able to write them down. Like let's look at C here. You know you're going to get an m squared. You know you're going to get a minus 16n squared. And then you look and you're saying a 4mn and a minus 4mn, those cancel out. This is a difference of two squares one, okay? So like this guy here, b, you know you're going to get that times that. That's a 4x squared y squared. You know you're going to get a minus 9. You know you're going to get a 6xy and a minus 6xy, and those cancel out. This happens to be another difference of two squares one. Okay, let's look at D here. This is the same thing as 2u minus 3v times 2u minus 3v, right? Because we're squaring it. You don't want to have to write that out to write the answer down, right? You know you're going to get this times itself. You know you're going to get this times itself. And you know you're going to get this times this and this times this, right? And those are the same thing. It's a 6uv. And since you're going to get two of them, and they're both negative, you got a minus 6uv and another minus 6uv. You get two of them, so you could just put a 2 there. This is where one of the, that's this one, part 3. But I mean, you can write it out if you want and do first, outer, inner, last. You got the 4u squared, you get the positive 9v squared, the minus 6uv and another minus 6uv gives your minus 12uv. Okay, so you want to be able to do these in one step, basically, just write down the answers. All right, practice it till you can do these in one step. Something like this right here, cubed, that's harder. 2x minus y cubed. Well, let's multiply this one out. How would you do that? Well, this is 2x minus y times 2x minus y squared, right? Well, that's 2x minus y times a 2x minus y times a 2x minus y, right? How did you even begin? Okay, well, what you can do is just keep this guy out front and multiply these. That gives you a 4x squared, a minus 2xy, another minus 2xy, and then a positive y squared. So you have the 2x times this guy, right? And you have a minus y times the same thing. So then you have to distribute. You'd have an 8x cubed, a minus 8x squared y, 2xy squared, a minus 4x squared y, a positive 4x y squared, and a minus y cubed. Right? You got a cubed here, you're expecting to get cubes. That makes sense? There is a trick, Pascal's triangle. So if we're doing x plus y to some integer power, you draw your triangle. 1 plus 1 is 2. Let me do a bunch of ones here. 2 plus 2 is 3. 2 plus 1 is 3. 2 plus 1 is 3. 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 4 plus 1 is 5. 6 plus 4 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And you can keep going. This is 0, 1, 2, 3, 4, 5. So x plus y to the 0 power, 1. Anything to the 0 power is 1. X plus y to the first power is x plus y, right? 1x and 1y, we don't bother writing it, right? X plus y squared is 1x squared plus 2xy plus 1y squared. 1, 2, 1. 1, 2, 1. So x plus y cubed, these are your coefficients. 1x cubed plus 3x squared y plus 3xy squared plus y cubed. Notice the x's go x cubed, x squared, x to the fourth, x to the 0. Y cubed, y squared, y to the first, y to the 0. So x plus y to the fourth power, look right here, would be x to the fourth, 4x cubed y, 6x squared y squared, 4x to the first, y cubed, and then 1 y to the fourth, right? These are your exponent or your coefficients. 1, 4, 6, 4, 1. So it just happens to turn it out that way. Pascal's triangle. And this thing has all kinds of patterns in it. There's a lot going on in Pascal's triangle. It's not just used. These are called binomials. Something plus something to higher powers. This always tells you the coefficients. All right, so now we're skipping to appendix 3. All right, because we want to factor now. We want to go the other way. If you have something like this, first thing you want to do is find your GCF. What is the biggest thing I can pull out of both of these? Well, look at the numbers first. The biggest number I can pull out is a 2. And this one only has 1x. This one has 2. So the most x's I can get out of both of them is just 1x. And then both of these have at least a y, so I can get a y out. So the first thing you want to do is pull out whatever you can. That'll come out from everything, right? So that's your GCF there. That's the biggest thing you can pull out of both of those. This guy, I can pull a 2 out of both of these, and I can get an x out of both of those. So pull out your 2x, right? So first thing you do is write 2x. We'd have an x squared minus 4, right? That's the x cubed, and then the minus 8x. And then you'd look at this and say, well, that's the difference of two squares, right? 4 is 2 squared. So I still have my 2x here, but this is an x minus 2 times an x plus 2. You got your x squared, you got your minus 4, minus 2x plus 2x, the cross terms disappear, all right? So you want to be able to factor stuff like this into that pretty quickly, right? Like this guy here, how would we do that? It's an x squared, the leading coefficient is 1. So when I see something like this, where the highest thing is x squared and there's no number here, I automatically put my parentheses, and I know I need an x and an x to get an x squared. I know I need two numbers that multiply to give me a minus 6, but they have to add to give me a minus 1. So I know it has to be a minus 3 and a positive 2. There's my minus 6. I get a minus 3x and a 2x. Those will add to give me the minus x. So that's eyeball method. If there's no number up front here, you can eyeball method it. Okay? Not everything is factorable, right? Right? There's only two possibilities, right? Well, 4 technically. You can have a minus 3 times a positive 2, a positive 3 times a negative 2, a minus 6 times a 1, or a 6 times a minus 1. So there's 4 choices to get that. You need the one that gives you that, though. Like this guy here, the numbers, I can get a 5 out of both of them. So I pull the 5 out, but that's all I can get out. This doesn't have any m. So I pull the 5 out. This is not factorable. I cannot factor that. This is the sum of two squares. You can't factor the sum of two squares. Okay. So that we would call these factored completely. You can't, and you got to have integer coefficients. That's what the key is. The numbers in the front have to be integers. You can always factor if you're willing to use decimals and stuff like that, but we don't want to do that here. Or imaginary numbers. So you've seen examples like we just looked at before, right? This is basically review. So for A here, the first thing I do is look at the numbers. I know I can get a 3 out of everything. They all have an x, so I know I can get an x out, and they all have at least a y, so I can get a y out. So for this thing here, I have a x, I'm going to need an x squared. There's my x cubed. I already got the y. This guy's negative. To get a 6, I'm going to need a 2. I need x squared y squared. Well, I only have an xy, so I'm going to need another xy. Now for this one, I already got the 3, but I don't have the minus. I already got the x. I need y cubed. I only have one y, so I gotta have a y squared. So that's the first step. Pull out the GCF. Now this, I can factor it. Because there's no number in front of that guy and no number in front of that guy, that makes it easy. I know I need an x to get the x squared. To get a minus y squared, I know I'm gonna need a plus a y and a minus a y, right? But I have to check, does that give me this, right? This is, we got the x squared, we got the minus y squared. I got a positive xy and a minus xy. Those would cancel out, and it's not giving me that. So that doesn't work, right? Eyeball method is try something and check, right? That doesn't work. So we can't factor this down anymore because those are the only chances. The only thing you can get a minus y squared is a plus y and a minus y. Okay. If this was a positive, that would be different, right? But it's not. So we're stuck. That's it. Done. B, check this out. This is the same thing, right? A 2y plus 5. So we have a 3y and we have a 2, and they're both being multiplied by 2y plus 5. So y'all are used to going one way where you see this, right? Y'all are used to like, I can multiply this out, right? But you want to go the other way. This is whatever, A. It's 3y times that and a 2 times that. 3y and a 2, both times the same thing. This is the same thing. So we can factor this dude out. Basically, we just need to do a whole lot of examples of this. We're going to factor this guy, factor all. The first thing you want to do is get your GCF. I can get a 2 out of everything. They all have X's. They all have a Y. The first thing I'm going to do is pull that out. So that gives me an X squared, right? That times that is 2X cubed Y. For this one, I need a minus. I'm going to need a 4. I need an X squared, I only have 1X. I need a Y squared, I only have 1Y. And now for the last one, to get the 6, I need the minus. 2 times 3 is minus 6. I have the X. I need a Y cubed, I only have 1Y, so I need a Y squared, right? At that point, I'd have to try to see if this is factorable, okay? And I could be like, okay, this is hard because there's a number there, right? So I know I need an X and an X to get that, but I need 2 numbers. I don't have to have a Y and a Y to get the Y squared, but they have to have numbers in front to get that minus 3. To get a minus, one of these has to be plus and one of these has to be minus, right? Positive times a negative is a negative. One of these is going to have to be a 3 and the other one a 1, right? But if I do it like that, yeah, I get my minus 3y squared. But look, I get a positive 3xy minus xy. Well, a positive 3 minus 1 would be a 2xy. I need a minus 4. So that tells me that the other option, the only other possibility is this, right? Y times a minus 3y gives me that. If I do it this way, I get minus 3xy plus xy. Well, that's a minus 2xy. I need a minus 4. So that tells me this thing's not factorable, that I'm done here. Okay. So B here, we have the same thing. So we have this 2x and we have a minus 7, and they're both being multiplied by a 3x minus 2. Okay. Factor by grouping. So here's a trick called factoring by grouping. You've probably seen this before. When you see there's 4 things here, it's only a second order. Why did they not collect these like terms? Right? I could collect these like terms, but they've actually written this out. This was originally minus 4x, but they did a trick to write it like this, right? They could have written it as minus 2x minus 2x, right? Why did they pick this? You'll see why in the next section. First off, as is, if we separate these, this first thing here, I could pull a 3x out, right? And that would give me an x minus 1. Okay. Now this guy, if I can turn this into something times x minus 1, in fact, if I pull a minus 1 out, I can write it as x minus 1. You see, you get this thing twice. So at this point, I could say it's a 3x and a minus 1, and they're both being multiplied by x minus 1. That's why they wrote minus 4x like this, because it allowed us to factor by grouping. Okay. In the next section, they're just going to give you this, and you're going to have to figure out how to rewrite it in order for the grouping to work. So this one, again, this is minus 8xy. They wrote it this way because that's how you have to write it for the grouping to work. If we look at the first 2 terms, I could pull a 2x out, right? I get an x minus y. And now for this one, can I turn this into something times x minus y? Well, if I pull a minus 3 out, minus 3y out, they both have a y in there. I would have a 2x. No. Yeah, 2x minus y. Let's speed something up. This is a 2 here. 2 times 2 is 4. Okay. So now these are the same. So I could say, well, I have a 2x and I have a minus 3y, and they're both being multiplied by 2x minus y. So that's one of the steps in factoring, is grouping. So this guy here, you couldn't even combine these, can you? None of these are like terms. There's nothing we can do there. But for the first ones, there's nothing I could factor out of those. Those I could pull a y out, right? Nothing I can factor out of here. So what I would do is I'd be like, well, those both have y's and those both have z's. So if I just rewrote this a little differently, if I just switched these two, that's all I did was just reverse their order. Now these first ones, I can pull a y out. And on these, they both have a z. I can pull a z out. X plus y and y plus x, those are the same thing, right? So I have a y and I have a z, and they're both being multiplied by an x plus y. And now it's factored. I turned a sum into a product. So that's the goal. Sometimes you have to rearrange them or write them a little differently, okay? All right, this guy, that's 11x. Why did they write it like that? Well, because if you group, I could pull a 2x out of the first ones. I would get a 3x plus 1. And I can turn that into something times 3x plus 1 as well. If I pull a 3 out, I got a 3x plus 1 again. So I have a 2x and a 3, both multiplied by 3x plus 1. Y'all remember doing this? Factoring by grouping? All right. So the same thing here. We group these. The first ones, we could pull a 2u out. That would give us a u plus 3v. Here, I could pull a minus 3v out. That would give me a u plus 3v. So since we have that twice, we have a 2u and a 3 minus 3v, both being multiplied by u plus 3v. Here's 4 terms. These have nothing in common. Those have nothing in common. But if I switch these and to switch the order of those, you see these both have C's, these both have D's. So here I could pull a C out, and here I'll pull the D out. Right, A plus B. So now I got the same thing twice. I have a C and a D, both being multiplied by an A plus a B. Make sense? All right, can y'all do this swiftly? Got to practice. It's a lot of practice. You have to be able to do this quickly. All right, this is the appendix. This is stuff that y'all are already supposed to have mastered. But this is why you're in the co-rec class, because you haven't mastered this. That's why we have a 2-hour class instead of a 1-hour class, so that you can learn this stuff. Factoring, AC test for factorability. I don't know what that is. So not everything is factorable. How can we tell if it's factorable? We always write this. You'll see that written a whole lot. Ax squared plus bx plus c. This is what we call a quadratic. It's a number times x squared, a number times x, and then a number, right? This is x squared. Remember I told you x squared looks like this? This is x squared, but it's been shifted and moved and stretched, all right? We want to be able to graph these, find the vertex, stuff like that, okay? So this is one single variable, this is 2 variable. So they say, look at the product of A times C. Whatever that number is, your leading and your last coefficients. All right, multiply them together. the product AC has two integer factors, P and Q, whose sum is B. So it's easier to do an example here. So like I said, up here, how did they know to write 11x as 2x plus 9x? That's the trick, okay? How do you figure out 2 and 9, okay? And I'll show you. I call it the AC method. I don't know what they call it. But here's the trick that allows you to factor them. So if there is a quadratic here where there's a number out front, then it's a pain in the ass, right? If there's no number there, you can just eyeball it. You can be like, I need an X and I need an X, right? But as is, if you try, one of their main methods is guessing. If you try it like this, to get X squared, you could be like a 2X and a 2X, or I could do an X and a 4X, right? Okay, and to get a -3, see, I'm gonna have to do this again, because to get a -3, I could do a -3 and a 1, or a 1 and a -3, right? The two X's here. Or for the X out front, I could also do a +3 and a -1. Those are the four possibilities that give us the outsides, right? 4x squared -3, 4x squared -3, 4x squared -3, 4x squared -3. Those are all the possibilities, but we need the one that gives us a -4x here. So we would be like -6x plus 2x. That's the one that works, right? If we tried the others, it just so happened that I wrote the right one down first. I just guessed it, right? But look at this one. We have 7x minus x. That would be a +6x. So no. A +2x. My other x here. A +2 and a -6. That would be a wait. Oh yeah, this one works. These are the same. 2x minus 3 times 2x plus 1, 2x minus 3 times 2x plus 1. Those are the same thing. Oh, and these are the same thing. All right, so I guess there's just two possibilities, or I wrote them down wrong. Anyhow, we managed to guess it, right? Guessing sucks. How would we do this if we didn't want to guess? Here's the trick. I think it's called the AC method. I call it the PQ method. Here's the trick. What you do is you look at A times C. This is A, this is C. A times C is -12. And you also look at B. B here is the -4, okay? What we need is two numbers. I call them P and Q. You can call them whatever you want. We need two numbers that multiply to give us the same as this, but they add to give us this. This is the trick right here. What is P and Q? So you start thinking about it. Two numbers that multiply to give me -12, but add to give me a -4. A positive, no, a -6 and a +2. They multiply to give me that, and they add to give me that. These numbers tell you how to break this guy up. These tell you to rewrite this as a -6x plus 2x. That's how they figured out how to write those, right? That's what that's for. And now you can do grouping. So here I could pull out a 2x, and here I need to write this as something times 2x minus 3. Well, it's already 2x minus 3, right? So I would write it as a 1 times a 2x minus 3, right? This is the same as that, right? I have something times 2x minus 3. I need to write that as something times 2x minus 3. The something here is 1. So you see I have a 2x and I have a 1, both being multiplied by 2x minus 3. So this trick right here, if there's a number out front, you can always do this trick. It's that trick every single time, right? It's that, or you can just guess like we were doing a while ago. Guessing sucks, right? Because sometimes, like the last problem, there's only 2 possibilities, right? But if there's numbers, these numbers are big, then there could be like 64 possibilities, right? So if you're looking over here and there simply is no 2 numbers that you can multiply that give you that and add to give you that, if those numbers don't exist, then it's not factorable, all right? So you just have to go through all the possibilities. What are the numbers that multiply to give you that and add to give you that? So the key here is doing lots of examples. You just have to practice a lot because it is pattern recognition is what all this is. So this guy, we could do our guessing thing, right? Guessing sucks. To get a 2x squared, I could do a 2x and an x. That's the only thing you can do, right? Because 2 is prime. Okay. 2x and an x. To get a minus 4, though, I could either do a positive 2 and a negative 2, or minus 2 and a positive 2, right? See, here the minus is with the x, here the minus is with the 2x, right? Which one of these is it? I mean, both of them give us our minus 4. Both of them are giving us a 2x squared. The first one we got positive 2x minus 4x. Positive 2 minus 4 is negative 2x. This is a minus 3, so that doesn't work. Here we have a minus 2x plus 4x. That would give us a positive 2x. But we have a minus 3, so that doesn't work. Those are all the possibilities. So this dude is not factorable. Okay. But I don't like having to do that. I'd rather do the AC method. If I was doing this, I would be like, okay, A times C is minus 8. B is minus 3. Are there any 2 numbers that multiply to give me that, but add to give me that? All right, what is the P and what is the Q? All right, they have to multiply to give me that, and they have to add to give me that. Well, what are the possibilities? I could have like a minus 8 and a 1, but they don't add to give me that. Of course, a minus 1 and an 8, they don't add to give me that. I could do a 2 and a minus 4, but they don't add. I could do a minus 2 and a positive 4. They don't add to give me that. And there are no other possibilities. So there are no 2 numbers. That's how you would know this thing's not factorable. C here is a little harder because we got some y's over here, right? If we tried to eyeball it, for this, we could do a 6x and an x, right? Or we could do 3x and a 2x, right? Those are the 2 possibilities. But over here, we could either have, here's a trick here though. This is minus, but this is plus. That means we're going to have both of them being minus. We can't have both of them being plus. Because if they were both plus, when we added, we'd end up with a positive number here. So we could either have a 4 and a 1, or we could have a 1 and a 4. All right, so we have to do both possibilities because we have 2 possibilities for the first, 2 possibilities for the last. That gives us 4 total, right? So we could do a minus 4 and a minus 1, or a minus 1 and a minus 4. Those are the 4 possibilities, right? And they have to be both minuses because these have to add to give us a minus. So this one is a minus 4x minus 6x. It's minus 10. Oh, and I forgot about my y's here. So I need a y, 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 and a y. See, now I'm getting the y squareds. The y squareds, right? Luckily, this is an x and a y. You see, if I do, that's an x times a y, and this is the x times the y. So even though there's x's and y's, it doesn't have to make it any more difficult. As long as these are squared, and this is a combination, right? You're getting minus 4xy, minus 6xy, that's minus 10xy, but we need a minus 25, so no. Minus xy, minus 24xy, that gives me my minus 25xy. That's it right there, that one. Now see why? Minus 1xy, minus 24xy, that gives me my minus 25xy. So that's how you would guess it. The guessing sucks. How would I do this with our trick? Because again, the guessing only works if there's only a few possibilities, but sometimes there's like 800 possibilities, right? There's 800 possibilities. You want to do the method that works every time. My A times my C is 24. My B is minus 25. We need two numbers that multiply to give me that and add to give me that. So what are my two numbers? Well, I start thinking about numbers here that multiply to give me that, but add to give me that. Yeah, so 20, negative 24 and negative 1. They multiply to give me a positive 24, and they add to give me a negative 25. So that tells me how to break this middle term up. I'll write it as minus 24xy and then minus an xy. That's what those numbers are for. So now I can do grouping. So out of the first ones, I could pull a 6x out. I would get an x minus 4y. Now I need to turn this into something times x minus 4y. Well, if I just pull out what a minus y, I will get an x minus 4y. So I have a 6x and a minus y, both being multiplied by an x minus 4y. All right. So again, you can guess if you want. We had to write down all the possibilities and then check each one, right? It's faster to do this. Okay, unless it's real simple. Again, this is really simple. 2, 3, 4, right? I mean, 25 is kind of a big number, but 6 and 4, there's only two numbers you can multiply together to get those, right? A 3 and a 2, or a 6 and a 1, or a 4 and a 1 and a 2 and a 2. So there's only four things to check. Okay. Blah 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 blah. So here's your exam, parts A through C for the day. You just want to factor if possible. Remember how to figure it out, right? You can do your trick.